Hi everyone, we're going to go over the extra subtraction postulate question that I gave you for homework. This is similar to last week's homework that I gave you where you had to do possibly a little bit of research on your own or maybe a little bit of searching your memory banks for something from a previous class where you did a little bit of geometry as a singular chapter within there. What you needed to remember or find was that V, W, Y, V, X, Z, things like this, rays or even line segments or lines, they might be comprised of a few angles put together. However, they themselves have 180 degrees total in them. So knowing that straight lines, segments, or rays have 180 degrees is important. And so besides the givens which I had pre-printed for you, we, knowing that those were two rays, can say something like what I already have written down here in step 2, that angle 1 and angle 2 equal 180 degrees. And the reason for that is going to be something worded like this. It doesn't have to be perfect, but adjacent angles forming and I'm going to say ray in this case since we have a ray, total to 180 degrees. You could have done potentially something similar to this, but a little bit different in saying maybe that instead of this equaling 180 degrees when I put angle 1 and angle 2 together, that these two separate pieces shared that fact in common. Because I haven't done anything in my statement yet to mention the other side of this figure. However, because it's going to share the same reason, this is still a ray with adjacent or angles that are next to each other, making that straight portion. I could say maybe numbering these 3 and 4 in this same step because of the same reason that angle 3 and angle 4 are also doing that. And so because these are rays being formed by separate angles, but these angles come together to make 180 degrees, both of these statements end up being true. However, you'll notice they both have the same fact on one side of their equal signs. This allows us to use our transitive property. We can now say angle 1 plus angle 2 is equal to angle 3 plus angle 4. Now, the other given that I have kind of ignored so far, if we look at it, mentions an angle called YWX. YWX is what I have named angle 2. It is congruent to an angle ZXW. ZXW I have named angle 4. So we happen to know that those two angles are equal to each other. What this allows me to do is to swap out one of those, such as angle 4, for its equivalent, angle 2. And that is known as the substitution property. And now that I've substituted one out for the other, you'll notice on both sides of the equal sign, I have an angle 2. So I have the right now to do what hopefully you remember from algebra class as the additive property of equality. But additive property of equality was if you added or subtracted the same thing from both sides. In geometry, we're going to use this and replace that statement with what's known as the subtraction postulate, where we are allowed to go ahead and subtract the same item from two sides of an equality. So this is known as the subtraction postulate, post for short, post. And because we have a plus angle 2 and minus angle 2, those will cancel out. A plus angle 2 and a minus angle 2, those will cancel out. We've essentially subtracted the same item from both sides where it was already existing. We were able to simplify this statement, or we did some simplification here. And we have simplified it so only angle 1 is on the left and only angle 3 is on the right. Angle 1 has another name. It ends up also being VWX, which we will see right here. And angle 3 has another name, VXW, which we see here. And so we have finished our proof.